Hello and very welcome back. So as you can see today we are going to discuss a very special and very popular topic in the field of integrated circuits that is known as FPGA. So this stands for Field Programmable Gate Array. As you can see that this is the central IC right over here, also a central IC. This is called as FPGA, and when such IC is embedded in the board, as you can see the surrounding is the printed circuit board, it is called as FPGA board. So what is an FPGA? So as I said, the word FPGA stands for Field Programmable Gate Array. So as the name suggests, this is an IC which you can program again and again to realize any digital logic. From simple logic gate to complex functions, you can realize any logic into it. So this is a configurable IC, reconfigurable IC, and there are millions and millions of logic gates inside which you can program, and you can interconnect those gates to each other to realize a Boolean expression or logic function to from simple one to the complex one. So inside it, you can say that FPGA is a matrix of configurable logic blocks, in short form CLB. So you can have those logic blocks, as I said before, reconfigured again and again. And those logic blocks, they are connected via programmable interconnects. So it's a kind of switching function. You can connect logic functions to each other to realize bigger and bigger logic functions. So FPGAs can be reprogrammed to desired application. Any desired application that you want to implement, you can have it configured inside this IC, and then you can use it for some specific field in medical, avionics, instrumentation, industry, etc. So basically, most of the FPGAs are SRAM based. It means this stands for static random access memory. So you can actually erase it and again reconfigure it with some other application for some other application. So you realize one function into it and then you erase it. You can then reprogram it to realize another function. So this is the speciality of this IC. So you can say that this is a blank IC, and up to your wish, depending on your requirements, you can program it to achieve your target application. So this is as opposed to the ASICs. So before that, I wanted to say that there are FPGAs available in the market also, which can be programmed at once only. Once it is programmed and that is fixed, and then you can deploy it into your industrial application where it is targeted for. But most of the available FPGAs in the market, they are SRAM based. Now, FPGA and ASIC, there are difference. A fundamental difference is that application-specific integrated circuit. What you see in the market, you also have some ICs, that is integrated circuit. So those ICs have been manufactured with the desired functionality already designed into it. So for example, analog to digital converter, digital to analog converter, oscillator, amplifier, instrumentation amplifier, buffer, clock, etc. So any function you can think of, you see that whether analog, digital, or mixed signal ICs, those ICs are fixed, and after manufacturing, they have been fixed for their functionality. They cannot be programmed or reprogrammed, but FPGA gives you facility to program it again and again. So finally, you would say that FPGAs perform everything from the simple logic gates to the complex functions. So you can realize, for example, simple AND gate, OR gate, NOR gate, to a complete system on chip onto this particular IC, because there are millions of gates and those gates can be interconnected via programmable interconnects. So you see that this is an example board from the Statix IV family FPGA from this company right over here. There is this IC, only IC shown here. This is called a Spartan FPGA from this company right over here. Okay. So if we move forward, so today's FPGAs have a lot of features in the market. We are in 2024, and you will find that the FPGAs are available with a clock frequency of 500 megahertz, which cross the performance barrier. Easily, you can find those speedy, very fast FPGAs in the market. You also have unprecedented logic density. It means in this IC, you have millions and millions of logic gates, which you can use to configure any logic functionality, any Boolean expression, any or even complete SoC, system on chip, for your target application. So those are the powerful feature of today's FPGA. So for example, this board, as you see in the central, you have an FPGA IC, which is Statix IV, that is the family of the IC. And surrounding, you find that all these ICs, interconnects, some passives and some connectors. So you see that there is a crystal also. So all these parts are embedded processors, DSP blocks, clocking, and high-speed serial at even lower prices. So the prices are decreasing and functionality on the FPGA boards are increasing with unprecedented features. Okay, so where are the FPGAs used? Basically, you would find their applications in different and variety of fields. So for target applications in the aerospace and defense, you find FPGAs are used. ASIC prototyping, for example, you want to fabricate an ASIC. Once it is fabricated, the function will be fixed. You cannot change it later. So for that, you are not sure, and you are going to have a volume manufacturing of the ASIC IC, let's say the tens of thousands of ICs. But before that, you want to verify whether the ASIC it will be functioning as desired. So you have these blank FPGA ICs. You can actually implement that ASIC logic into the FPGA first. This is called as FPGA prototyping. It is quite rapid, fast, and you can verify the functionality of ASIC into FPGA first. And then once you are satisfied, you can send it for the volume manufacturing of those ASIC ICs. For automotive applications, you find that you have a driverless cars, driverless automobiles nowadays, and you need advanced digital functionalities, digital processing and all that. So FPGAs can be deployed for this purpose. You have medical instrumentation, you have consumer electronics, you have industrial applications. A lot of features are there where FPGAs can be used. So how is FPGA configured? That is the basic function. When you want to implement any logic inside it, how to program it? That is the question. So you would have the usual procedure, what you do while doing the ASIC manufacturing, ASIC designing. You start with the schematic entry if the logic function to be realized is of a small level. But if the logic function more than 100 gates, let's say thousands and thousand gates, you basically take help of hardware description language. So basically you're writing a code to describe a hardware, what you usually do with the ASIC. So you will do the same for the FPGA configuration as well. So you use VHDL or Verilog language where you write a code to describe the hardware, and then this design is compiled. You then simulate it to verify the timing and other functionality, and check the Boolean expression, the truth table of your logic, for example. And then you synthesize that design. Synthesizing means implementing your code into a realizable logic gates. And then once your design is synthesized, your design then can be translated into bit stream that is loaded onto this blank IC. And then inside you have those CLBs, which basically features the logic gates, mux, flip-flops, etc., which can be connected to each other through the programmable interconnects. So internally, FPGA uses logic gates, as I said, flip-flops as a memory, as a simple memory, and you also have advanced memory blocks inside these ICs. So how many gates nowadays inside the typical FPGA? So here in these FPGAs, nowadays you have more than 50 million gates. So this company which provides the FPGA feature those gates capability. Okay, what are the companies that are providing the FPGA ICs and the boards? So here are the companies: Ultra, Altera, Actel. These are the two major companies earlier in the 90s that were producing the FPGAs. But nowadays, you have companies like Intel, Xilinx, Lattice Semiconductor, and Microchip Technology. They are the major FPGA providers. Okay. So inside this, as I said before, you FPGA contains the CLB, configurable logic block. So inside one CLB, you have this schematic representation. So we are going to delve deeper into this in some other lectures, but right now we have a general overview of this schematic, which sees that most FPGAs will contain your CLBs. So each CLBs, they are also called as logic array blocks. So some manufacturers call them CLBs, some other manufacturers call them logic array blocks, LABs. Okay, so this is a simplified example illustration of a logic cell. One logic cell basically contains the lookup table, full adder. This is the lookup table, LUT in short, full adder right over here, and the D flip-flop right over here. So this one complete blocks together, they make one logic cell right over here. We are going to explain details of it in some later part of the lectures, but right now we'll see that okay, most FPGAs will have such logic cells, and outside you have the input output pads for the external world connections. So right now here you can see that this is a typical FPGA board. There are two FPGAs right over here, and inside the ICs you have this logic cells. There are multiple logic cells, thousands of such logic cells, and then in the outside you have input output pads, and then those logic cells are or can be connected to each other through the routing channels. Okay, so like I said, Altera, Actel, and Xilinx are now the three major companies. They are producing a lot of FPGAs with different capabilities, different features. Okay, so hope you found this module useful. If you did so, share it with others for a wider reach, and share it for a wider reach. Stay tuned for more engaging content like this. We are going to produce more content related to FPGAs. We'll also explain the details of these blocks, and we'll delve deeper into the FPGA architectures. We'll explain through the block diagram illustration how those logic blocks can be configured through a routing channels, how IO pads are used inside the FPGAs, and we'll show you one by one. So stay tuned, and till then, wish you all a very happy learning.